this video, what we're going to do is we're going to talk about confidence intervals. Confidence intervals give us that range of values that is likely to contain the true value of the value that is being estimated. Because we don't have the actual population mean or standard deviation or population proportion, we have to estimate those. And so our estimations, we want to be as accurate as possible. And so with confidence intervals, that's what we're trying to do. And we want to estimate that range in which it can be. And so these confidence intervals are where we think the true value is going to be. Many of us have seen on different surveys, results, things of that nature, this little bitty plus or minus says 0.2. What that is that is our margin of error. So we have 95% plus or minus 0.2%, something along those lines. And so we're saying it's 95%, give or take a little bit. That give or take is part of that confidence interval, meaning add and subtract that 0.2%, and that gives us that margin of error, that little bit of interval, giving us that confidence that we need in order to think about where the true mean is going to lie. And so what we're going to do is we're going to study about these confidence intervals in this video for the population mean. When I talk about point estimate, it's just a single number that we use to estimate the value of an unknown parameter. And so for the mean, of course, x bar is a good point estimate for the population mean. And the sample standard deviation, S, is a good point estimate for the population standard deviation, sigma. Just like p hat, the sample proportion, is a good point estimate for the population proportion, p. Now we do these things so that we can look at margin of error, just like I talked about that plus or minus interval. The margin of error is the largest distance from that point estimate. It's the largest possible range that we want from that point estimate that the confidence interval will cover. And so it is that plus or minus portion. So if I have x bar plus or minus my margin of error, this is what we're talking about, that plus or minus value there. In order to find that margin of error, that m, that plus or minus value, we've got to look at some critical values. And we look at z-scores, that is, if we know the population standard deviation. We'll get into some other things where we don't know the population standard deviation, and we'll discuss how to find those. But right now what we're going to do is we're going to talk about when we can locate the population standard deviation. We're going to look for the z-score. Well, the z-score that we're going to find is for the middle percentage. Because when we're talking about confidence intervals, we're looking here, looking at the standard normal curve, and we're going to look at the middle, say 90–95%, however confident we want to be. And so that's the middle, because we want this confidence level with a little bit left on each side. And so we're looking for that middle portion. Well, if we take out the middle portion, that means that we need to find out how much is left over in each end. Well, if this is 95%, that means that each side is going to be 1 minus the 0.95 divided by 2, because it's half of it's left on each side. And so that means that this portion is going to be a 0.025. And this portion is also going to be a 0.025. And so we have a little bit left over on each side when we're talking about these tails. And so to find the z-score for a 95% confidence interval, just like we were discussing, if I draw that normal z-score here, there's 95% here and 2.5% on each side, which would leave me with a 0.025 here and a 0.025 here. There's a couple of different ways I can do this. One way is to look up 0.025 in the center of the z-chart. So let me pull up the z-chart, and I want to find 0.025. So if I look up 0.025, that's going to be right here. And I follow it out. So that's going to be a negative 1.9, and I follow it up. So a negative 1.96. Okay. So I go back. This over here is a negative 1.96. Remember that this is a symmetric chart. And so if this side is negative 1.96, that makes this side a positive 1.96. This is one way of finding our critical value, our z-score. Another way is we can look at the bottom of our t-chart. You'll have a t-chart available to you, and at the very bottom of that t-chart, you will have this confidence level and the z-scores down here. Now this is only for certain confidence levels, so if it's a different confidence level, you will have to do it the way I just showed you. But for certain confidence levels, you can find your z, like our 95. Here is the z that we will be using, a 1.960, just like we just saw. Okay? And so that is another way that we can find our confidence or our critical value. So again, the z that we will use is a 1.96. And so it differs from each confidence level that you're looking at. Let's go back to that t-chart that I had up. And looking here, notice with a 99% confidence, we use a 2.576z. With a 90%, I use a 1.645z. And so these are some things to look at. Now, if you're wanting an 85% confidence level, you will have to calculate that yourself and use the other method of calculating that. Okay? So now then, let's look at the margin of error. So we found the critical value, and what we want to do is we want to multiply that by what we call our standard error. So we found the critical value of z, and we say alpha divided by 2. The reason why alpha divided by 2 is because it's that value that's left over on each side, so it's divided by 2 there. Okay? And then our standard error the standard error right here is our sigma divided by the square root of n, just like we talked about in previous videos. That is our standard error. And so this is what we call our margin of error, our z times our standard error, which is sigma divided by the square root of n. And so when we want to find our actual confidence interval, what we're going to do is we're going to take our point estimate, which in this case is going to be our sample mean, and we're going to subtract our margin of error, z alpha divided by 2 times our standard error, and we're going to take our point estimate plus our z alpha divided by 2 times sigma divided by the square root of n. The reason why I put the population mean in the center is that signifies what I'm trying to find. Okay? And so what I'm doing is finding the lower end of the confidence interval and then finding the upper end of the confidence interval. So practice finding some of the critical values in your margin of error, and then we will discuss actually how to construct the confidence interval in the next video.